All right, guys, welcome back. Today we're going to get into writing linear combination of unit vectors. So I'm just going to jump right into it. We're just picking up where we left off. So example 3 is let u be the unit vector with initial point -2, 6, which I've gone ahead and labeled as P1 and P2, and terminal point -8, 3, which I went ahead and labeled as Q1 and Q2. Write u as a linear combination of the standard unit vectors. All right, so the first thing we're going to do is find v, and we're going to rewrite it with terms I and j, which is going to look just like the coordinate when we put it in vector form. So I've gone ahead and wrote that here, the component form for vectors, q1 minus p1. So we have -8 minus -2, comma, Q2, 3 minus 6. All right, -8 minus -2 is -8 plus +2, which leaves us with -6. 3 minus 6 is -3. So this is the component form of a vector, and then to write it in a linear combination of units I and j, it will look like -6i minus 3j. So basically all we did was kind of rewrite it almost looking like an equation. But you basically just take away the parenthesis. I mean, not the parenthesis, take away, well, yes, take away the brackets, take away the comma, right? And then it's just -6 minus 3, and then you just add the I and the j. So the I goes with x, and the j goes with y. All right, and that is our first one. I will leave it just like that. All right, for example 4, let u equal -2i plus 3j and v equal 3i minus 2j. Find 2u plus 3v. So I'm just going to go ahead and rewrite it here. 2 times u is going to be 2 times -2i plus 2 times 3j. So just as we were doing before previously up here at the top, you're going to multiply both pieces by 2. And then we'll rewrite it here, which gives us -4i plus 6j. All right, and then we have 3v, which is going to be 3 times 3i minus 3 times 2j. All right, so we have 6i minus 6j. Whoop, that's a 9, not a 6. That's my bad. 3 times 3 is 9. Okay, so then we're going to add those together. So we have, when we add them together, we end up getting -4 and +9, which leaves us with 5i. So we're adding the i's together and we're adding the j's together. +6, -6, that's going to be 0. We're going to still write it 0j, because if we were to write it as a vector, it would be 5, 0. So you still want to have something there, even if it is 0. All right, let's look at the direction angles. Because v equals ai plus bj and tangent equals sine over cosine, or v times sine theta over v times cosine theta is equal to b over a. We're going to break that down and just kind of use these formulas here in order to solve example 5. And I've put a little information here that's going to help you. And it kind of goes along with this. Since tangent to the -1 is in the first or fourth quadrant, which is here, if it lies in quadrant 2 or 3, you have to add 180 degrees to put it over in quadrant 1 and 4. All right, if it's in quadrant 4, such as 350 degrees, you must add 360 degrees to it. All right, and that's going to kind of make sense as we go, because technically tangent the inverse tangent is a positive quadrant 1 or negative quadrant 1. All right, so keep that in mind. We're going to work through those and see it here. So V is equal to negative 6I plus 6J. So just before, this is the X value, this is the Y value. And let's just write it as if it were that coordinate, negative 6, positive 6. If it were a coordinate negative 6, positive 6, it would be in quadrant 3. Negative 6, positive 6, somewhere here. All right, that puts it in quadrant 2, Quadrant 2, not quadrant 3. So tangent theta is equal to y over x, which we have here. That is 6 over negative 6, which is negative 1. So because of that, tangent theta is equal to negative 1. And then so if we were to solve, it'd be tangent negative 1 of negative 1 is equal to our degree. If you were to look at the unit circle, or if you were to put it in the calculator, you would get that theta is equal to negative 45 degrees. All right, because it's in quadrant, because it's supposed to be in quadrant 2, which puts us, because negative 45 is somewhere here. In order for us to move it here, because it's in quadrant 2, we have to add 180 degrees to it. And you'll see that here. These are good notes to keep on the side because you will have to follow through with these. Once we do that, we end up with 135 degrees. All right, so even if you're struggling to understand why you have to do it, just keep these notes here and know that you do need to do it. All right, so if it's in quadrant 2, you'll have to take that degree and add 180 to it. Let's look at this one. So we have our x and our y. We've got the same thing. It's technically negative 5, positive 4. So we have a negative 5, positive 4, which again is in quadrant 2. So we will end up having to do the same thing. So we have tangent theta, which is equal to y over x, so 4 over negative 5. This is one where you would have to use your calculator. Tangent to the negative 1 of 4 over negative 5 would, if you use your calculator and make sure it's in degrees, you would end up getting negative 38.7 degrees. And because it's in quadrant 2, we have to add 180 degrees to it. Because technically negative 38.7 degrees is somewhere down here. In order to get it into quadrant 2 where it belongs, we have to add that 180 degrees. That will give us 141.3 degrees. All right, feel free to pause at any time if you need to continue to look over those. I'm going to fit these